All right, let's go ahead and talk about the pH scale. And what the pH scale does is it tells us how acidic or basic a solution is. Now, a solution that is acidic has a lot of hydrogen ions, and a solution that is basic has a lot of hydroxide ions. Now, the thing though that you need to consider is thinking back to the last set of notes where we talked about the self-ionization of water. Water always is going to have some amount of hydrogen ion and some amount of hydroxide ion. The thing is that when you add hydrogen ion to the solution, the amount of hydroxide ion decreases. And the opposite is true. If you add a certain amount of hydroxide ion, what will happen is the hydrogen ion will decrease. So expressing acidity or basicity in terms of hydronium or hydroxide ion can be cumbersome because we're dealing with things like 10 to the negative 6 or like 5.4 times 10 to the negative 3. And so what we do is instead we use the pH scale, which uses logarithms to make these numbers easier to work with. Now, if you're not in Algebra 2, you probably haven't learned about logarithms yet, and that's totally okay because you can still use the logarithmic function on your calculator. And so, and I'll go through that, how we do that. But whenever you put the letter P in front of anything, and this isn't just for pH, it's going to be for POH, and there's other things as well. What you're saying is that you've taken the negative log of that thing. And so, again, what it does is we have something like 5.4 times 10 to the negative 3. What the pH scale does is that will make it to where we can have a simpler number. In this situation is like the pH would be like 2.6 or something like that. And so the letters pH stand for this French word there that I'm not even going to try to say, which means hydrogen power. And so it tells us the strength of the hydrogen or the concentration of the hydrogen. And the pH of a solution is defined as the negative log of the hydrogen ion concentration. And so this here is the equation. Now again, if you're not in Algebra 2 yet, you probably haven't learned about this, and that's totally okay, because when we go through practice problems, I'm going to show you how to type them in the calculator. But it's the negative log of the hydrogen ion concentration equals the pH. Now the POH is the same exact thing. It's the negative log of the hydroxide ion concentration. So if we ever we're dealing with hydroxide ion concentration, we can calculate the POH by taking the negative log of the hydroxide ion concentration. Now, the relationship between pH and POH can be defined as pH plus POH is equal to 14. And so this is actually derived from the KW expression, and I'll show you in class how it is. But essentially, if we have, for example, a pH of 3, that means we have a POH of 11. If we have a pH of 8, that means we have a POH of 6. And so this will always be true at 25 degrees Celsius, that the pH plus the POH will equal 14. And we'll be using this a lot in a lot of the problems that we're going to be doing. So here are just general things to note. If you have a pH of 7, let's just start with a pH of 7. What that means is that you have equal amounts of hydrogen ion and hydroxide ion, and that's why we use that as a neutral. We call that neutral. And so again, if it's a pH of 7, you have equal amounts. Now, if you have a pH that's less than 7, so for example, a pH of 3, as you go less than 7, as you go as the pH drops below 7, that actually means that you are increasing the hydrogen ion concentration. And so what that means is that you're going to have more hydrogen ion or a greater hydrogen ion concentration than hydroxide ion. Now, if your pH is above 7, so you go if you go 8, 9, or 10, a pH of 8, 9, 10, 11, that means you're going to have less hydrogen ion concentration than hydroxide ion. And so as we go through practice problems, you'll start getting more familiar with these. But the key thing here that I want you to take away right now is that a neutral substance, they're the same. They're equal. Their concentrations are equal. Now, when considering sig figs with logarithms, there are as many decimals or as many digits after the decimal point as there are sig figs in the original number. And so notice the negative log of 1.0 times 10 to the negative 3. Well, the 1.0 is two significant figures, so that means that there's going to be two decimal places after. You're going to have two decimal places in your answer, which is why it's 3.00. So that's it. So really, when we do calculations, when we're doing these practice problems with pH and calculating all that, it starts to make a lot more sense. But again, the negative log of the hydrogen ion concentration is the pH. The negative log of the hydroxide ion is the pOH. pH plus pOH is equal to 14. And then we're also going to use the KW expression, or the equilibrium expression for the ionization of water, which is Kw, which is hydronium ion concentration multiplied by hydroxide ion concentration, to help us solve some of these problems as well. So that's all there is for this particular notes. Come to class with questions and have a good day.